Differential equations, we are in our 4.1 through 4.3 review, and we're on that third problem on this review. It says that we need to find a second solution, this time by a different method. We're going to use the formula method, and that's the formula method for reduction of order. It's really what we did in 4.2 day 2. So just real quickly, stating the obvious, you will be given a differential equation. You're going to be given a solution nicely. But you can think, well, how in the world can I get that second solution? Well, the second solution, this is what you need to know. Y sub 2 is equal to your first solution, y sub 1. Then we'll have this integral, big integral here. We're going to have e, and then it will be to the negative integral of p of x dx. We're going to have to talk about what that means in just a minute. And then down below we'll have our y1 solution squared yet again. And here's your dx. Well, of course, this right here is nice to have a formula. You already know what y1 is. I think what kids are definitely wondering, if they need a review, is, wait a minute, what in the world is p of x? Well, p of x, please understand that a differential equation, we will divide out whatever is in front of y double prime. And what is going to remain is your p of x, y prime. You'll then also have a q of x times y. But more to the point, what's super critical, I think what kids are going to realize is once you divide out, whatever's in front of your y double prime, your new equation will have a coefficient times y prime. That's your p of x. So look, we're going to revisit x squared y double prime plus a 2x y prime minus 6y is equal to 0. Here's our differential equation. You're going to say, wait a minute, I don't want to see an x squared there. I'm going to divide every term here by x squared, even the right side of 0 here. And what are we left with? Well, we're left with a y double prime plus a 2 over x y prime minus a 6 over x squared y is equal to 0. Well, I hope right now you can see that your p of x is going to be equal to 2 over x. So that's the good news right there. Now you know what you're going to use in your formula. And we can take that and say, hey, you know what? You already know what your y1 is. We're going to be plugging that in just as well. And then it becomes very, very mechanical. Let's do that together right now. Just finish this problem up. Your second solution will be y1, which now I can say, well, they told us it's x squared. And we'll have this e to the negative integral of 2 over x dx. That's your p of x. And down below we'll have our x squared squared. Then, of course, we have our dx. Well, just cleaning this up a little bit. You still have your x squared out in front. Inside here, you could bring the negative, inside if you'd like. You could say that's a negative 2 all over x dx, and down below here you'll have x to the 4th, right? But what is the antiderivative of negative 2 over x? Well, we could do that pretty quickly. We could say, well, that's going to be, we still have this e here. We're going to say that's negative 2, and then we can say that's the ln of x. We don't need a constant right there. We can just leave it, just keep it very general right now. And that negative 2 is going to come up. I guess what I really want to show you, just off to the side here, this is really like e to the ln of x to the negative 2. And what's that really going to become? Well, it's going to become x to the negative 2. So we've got this x squared out in front. Here we just have x to the negative 2. And please understand something. This is where kids can get really into some trouble. You have that x squared out in front. I just want to make a huge point. You can't pull what's inside the integral out when you're integrating with respect to x. Likewise, you can't multiply that x squared out in front in. You've really just got to, clean this up some. So let's do that. I still have my x squared out. This x to the negative 2 can come down, or if you'd like, you can bring up another x to the negative 4. This is really x to the negative 6th, isn't it? And then what? Well, let's take our antiderivative. Let's go ahead and take our antiderivative, and you can say, well, this would become x to the negative 5, right? Bump it up 1, divide by a negative 5. And then, of course, you'd say plus a c. But really, our focus is going to be just finding a general second solution. X squared times x to the negative 5th is really like x to the negative 3rd, right? And you could say that, well, you also have a negative 1/5 out in front of there, because you've got your 1 up on top and negative 5 down below. And you could also wonder if you'd need to multiply x squared into the c. You don't. Right now, you could leave this as an answer, or you could even say, look, I know that there's some constant that would be in general multiplied to a power of x. We could have just y sub 2 is equal to x to the negative 3. So you could have had your problem up above. You could also, just imagine that your c here is just a 0, just in general. You're trying to find a second solution. You want to find a real simple solution. And remember, in general, you have constants out in front of your function. Imagine a constant got multiplied to negative 1/5. It's just there. A family, a general family, would be that if you know that you had x squared for one solution, x to the negative 3rd for the other, what you'd see is, in general, we would write this. And then you can see why that negative 1/5 really isn't going to come into play. So hope this is helping. We're going to move on to a new video soon.